Now today's lesson is a speed measurement. So speed measurement is widely used in the industrial control application, followed by AC and DC motor speed control. So in this we use as a speed control method. So one method is that we use a tachometer. Tachometer is on the same shaft. The shaft is coupled with the motor shaft is coupled with the tachometer generator. So this tachometer is produced as a body. So this body, our body is that we write the speed. We are the speed proportional to the speed. So this is the place that we control the speed. Another one is that we can use as a stroboscopic light. Stroboscopic light is a light flashing. When the light flashing, so when the speed frequency is equal to the light flashing rate, so that you can see the shot in the stationary. So this is the way that we can utilize. So in this industry, we mostly utilize for the tachometer. The function we utilize the tachometer is it can not only measure the speed, it can also provide the positional control to provide the velocity feedback signal, and also you can set up the appropriate speed of the alternator, so to enable the synchronizing of the alternator can be done. So for regarding the tachometer, there are the two kinds: analog tachometer and also the digital tachometer. So now today we will give you the more detailed explanation about the speed measurement and the tachometer. So the speed measurement is widely used in the industrial control applications for the DC and the AC motor speed control. For example, tacho feedback modulation control to provide the velocity feedback signal, setting the alternator speed to enable the synchronizing of the alternator to each other and the system. So this is why we have to measure the speed control system. So there are the two kinds of speed control. So that way the DC permanent magnet tacho generator and the AC permanent magnet tacho generator. So these are the two kinds of the speed control tacho generator. DC permanent magnet tacho generator, and also the AC permanent magnet tacho generator. AC permanent magnet tacho generator. So DC permanent magnet tacho generator and there's AC permanent magnet tacho generator. So we usually utilize those tachometer in our practical level. So you see that all tacho, so those are DC type. All that motor driven AC drive system. Those are the motor share is coupled with the DC tacho generator. So in this case, DC tacho generator consists of the permanent magnetic field structure. So they call it a permanent magnet field. And also there's an armature with commutator segment. Armature with commutator segment. So in this case, when this DC tacho generator rotates, so that it can produce a voltage. So the output voltage is proportional to the angular velocity. So DC output voltage proportional to angular velocity. So this is why we can utilize as a AC permanent magnet tacho generator. Similarly, the AC permanent magnet tacho generator also this includes a permanent magnet rotor. Permanent magnet rotor. And also the permanent magnet rotor and also the polyphase stator winding. Polyphase stator winding. So there are two major components. So the output is rectified so that the output voltage and frequency is directly proportional to the motor speed. So in this case, the output voltage, the frequency is directly proportional to the rotor speed. So this is because the motor speed. Okay, so this is the two machines. So in this case, output is rectified to hit the DC signal. So output AC put to rectifier and convert it to the DC. So this is the way that we are constructing the tachometer meter. So there are two kinds of tachometer. One is the DC and another one is the AC. DC tachometers include the permanent magnet P and the ammeter winding. DC output proportional to angular velocity. Similarly, the AC permanent magnet tachometer is also called as a permanent magnet rotor. Polyphase theta winding, output voltage frequency proportional to the motor speed. So the output AC is rectified to the DC. So this is the one that we use as a tachometer. How we use it? Regarding the AC permanent magnet, another kind of the AC. This is another one we use AC induction tachogenerator. AC induction tachogenerator. This is for the AC. So in this case, AC induction means that this is for the popo. So this is the popo winding, and between this one we call it a drag cap. So this is for the cap, the metallic cap. So this is the here we use this is the shaft. And the outer wave that those are the pole winding. So this is the pole winding. So when we get the supply, so this is the output windings are connected to the pole. So the door windings are close to the magnetic flat. Those magnetic flats are rotated and dragged up. This is mounted at the center. So by the sense of weekends are produced as a tachogenerator output voltage. So when we are mounting the tachogenerator, we can directly put in carpet with the shaft, or we utilize as a bed drive with the shaft or the gear. The three kinds of tachogenerator mounting system. First method is a direct carpet. So motor and the tachogenerator are carpet on the shaft, or we can utilize a bed drive system on the gear carpet. For the direct carpet system, motor C and tachogenerator C are the same. But if you use the bed drive and the gear carpet, you have to use the ratio. You have to ratio between the gear tools and the diameter of the driver and the driving machine. You have to be calculated. But if the tachogenerator has an output voltage of 2 volt by 1000 RPM, the output voltage 3.0 volt, we have to connect it to the motor shaft speed. So in this case, every 2 volt, we use 1000 RPM. So voltage is 3.3 volt. How many RPM? So then multiplying 1000 divided by 3.3 divided by 2. So this is the 1000 multiplied 1.65. So this is 1650 RPM. So by this is our user in this case you have to standardize. One standard speed has to be fixed. So that based on the standard speed, particularly that you rotate the machine with the rated speed. So in this case, this rated speed you have to measure in other ways. You can either use the outside other tachometer or the other stroboscope. So this is the thing you can do. So measure the output voltage. Output voltage, the speed has to be you draw the graph, and any other voltage you can utilize this formula to calculate.
Is it just linear? I mean, the speed with the voltage?
In this case, depending on your tachogenerator. Tachogenerator construction for the permanent magnet one, the speed will be linear. If you use a series motor or shunt motor, that will be different. So this is why we use a permanent magnet. What is the digital tachometer? Digital tachometer is got two types of construction. One will use optical. And another will use magnetic. So in this case, optical digital tachometer. So what we use this is the wheel. The wheel is attached to the motor. And then here we utilize for the sensor. So either you use a sensor to reflection. So the better thing is you use this is a hole here. So this is a transmitter, infrared transmitter. So here we use the receiver. So when does this one is the motor rotate, the pathway is produced. So this is the output path. The rate of the path is depending on the speed. So the number of paths trained depends on the speed. So by the sense of when the motor rotating, the infrared transmitter transmits, so they are passing through the hole, so the output is the path are produced. So by the sense we utilize all the optics. And magnetic is we can also utilize a magnetic pickup. So magnetic pickup induce a voltage, and then we pick up. So this is what the magnetic pickup and the tools here we use magnetic pickup and tools here we. Yes, both are the frequency counter. So this receiver is attached with the frequency counter. In this case, you can use a decay counter or something. So this is we also attach to the frequency counter. So those frequency counters are the digital circuits. So we utilize. So this is the things this kind of optical method is also the encoder power train. So this is also we call the encoder power train. So this is the way that two kinds of spectrometers that we produce. One we use the analog type and another one we use the digital type. Okay, the next topic is the position measurement. So we utilize the precision potentiometer. Precision potentiometer means a potentiometer is similar to a voltage divider. So this one is a variable amp. Supply voltage constant. So this is we use the supply voltage here. So supply voltage. It's a 10 volt. And then we utilize for the this is a potentiometer here. So you got a wiper amp. So then we use the output voltage. So this is the way we utilize the potentiometer. So by adjusting to the wiper amp, the output voltage is proportional. So the amp position and the voltage are related. So this is the things you can determine the wiper amp position and output voltage are related. So by knowing the output voltage, you can also determine the position of the wiper amp. So in this case, normally we use this one is a linear type. Another one is a circular type. Circular type means this is one circular shape. Okay, this is a wiper arm. We use a rotate. So we can rotate. This is a wiper arm. So in this case, we can traverse. So traverse at 330 degrees. So this is a wiper arm. Similarly, we utilize a wiper arm here. So this wiper arm we also utilize. So this one also we rotate. So this is also at 330 degrees. So this wiper arms voltage we utilize. So when we have the wiper arm, so we get the voltage. Depending on the voltage magnitude, the wiper arm will the more. The moment angle has to be measured. So by the things the voltage is proportional to the moment angle. The voltage proportional to the angle of moment. Angle of travel. So this is the way that we utilize the potentiometer. So another thing is based on the distance technology, we utilize the position transducer and the receiver. Both position transducer and receivers are combined in the device synchro. This is synchro. So synchros are the steps synchronous machine. So synchronous machines usually we call as a synchro system. Or there's a Synchro has a resolver. Resolver means that this is a simple rotary transformer. So the relationship between the primary rotor and the secondary stator is a control by the sharp angle. Therefore, the voltage are induced in stator really acts as a function of the sharp angle. So this is the ways that synchros are working. These are the test machines. We also commonly call the synchros or the testings. A synchros and the resolver are the simple rotary transformer, where the relationship between the primary rotor and the secondary stator is controlled by the sharp angle. So this is called the primary rotor and the secondary stator winding. They control the sharp angle. Therefore, the voltage induced in the stator varies as a function of the sharp angle. So therefore, I draw a diagram of the synchro. Synchro got the two functions. One way is the transmitter and another way is the remote receiver. This is synchro here. Synchro got the resolver or the simple rotary transformer, where the relationship between the primary rotor and secondary stator is controlled by the sharp angle. So that when you change the primary position, so the voltage induced. The induced voltage also try to make the rotate the rotor. The rotor movement is depending on how much induced voltage. When this one is parallel, so there is no induced voltage, so rotor is at this position. When you rotate the stator, rotate the transmitter, so voltage difference happens. So those voltage difference happens, try to rotate the rotor. So this is the way that we use the synchro. The synchros are we can use like called the remote control system. Remote control system means that for the you use the voltage regulator. Voltage regulator is that rear voltage regulator are located in the side. But for your control room, you have to control the voltage regulator. In this case, we use a synchro. The synchro that you just adjust the transmitter, so the receiver angle we also follow. So this angle we are moving contact of the voltage regulator. So we utilize this time. This is the similar to the synchro, but synchro for the 180 degree difference, but the resolver for the 90 degree. So this is a similar thing. Encoder. Sharp angle encoder means depending on the sharp position, we can encode the sharp. So in this case, we can use like sharp angle encoder. This includes a pulse generator. So this one provides a digital output. So this digital output indicates a change in the sharp position. So now I give you the sharp angle encoder first. Let's absolute. The main thing is that this is for the sharp here. So this is become a LED. So this one is a light emitter. So when they are passing to the hole, so then we call the receiver. So then we say this is attached to the shaft. And this is what is rotated like this. So similarly, there's that kind of encoder system. So when the shaft is rotating, so this is the emitter like the passing through the receiver receive. So depending, so this shaft is we have to attach with the encoder. Encoder is two kinds. One is this is a black and white segment. So this is a black segment and white segment put on the color on the here. They are painted on the shaft. So this kind of thing is we call it increasement. And another one is the absolute. Absolute means that here is all black and white segments they are located in the same distance, but the absolute is different. Absolute is they are multiple segments. One way is this one is the black segment here, and another way is black segment we here like this, white segment we like this. So this is the black and white segments are these arbitrarily that we fit on the shaft. So that will be the absolute guide. So by using the absolute guide, we can this is depending on the black and white segments, it produces the path. The path the path nature is depending on how you put the increment or absolute. So depending on the path so it can the position, the path is proportional to the sharp position. So those paths when you produce. So there are two kinds. One way is the increment and absolute. Increment is all the black and white sectors they are separated equally, but the absolute is we bring that by this way. So this is by this that we can produce. we also utilize the positions as transducer. So then we use circular type and then linear type. So position transducer. There are two types. One with the circular, another with the linear. Linear. Those are the similar to the voltage divider. So circular type we use a 2 voltage. So this is for the proposed circuit here. We provide the voltage 12 volt. And this is for the we provide the 0 volt. And then this one is the output. The output is we put the output position. We change the output position so we can produce the output voltage. So this is we use the circular type. And also we can also use this for the in this case this position depending on the angle. So angle is the output voltage. Output voltage proportional to the angle. Angle theta. And now I have linear type. Linear type is this is for the linear. We put the linear potentiometer here. So this is a plus 24 volt and this is 0 volt. So that here we got 30 centimeter, 15 centimeter, 0 centimeter. So we put the output position. So this one is you can change. So we put the output. So this is the moment. So the length is depending on the distance, depending on the output voltage. So there's the output voltage proportional to the distance. So distance will be this is the D. So by this is we can measure the position of the shaft. So by measuring the output voltage, you can determine the position of the shaft. So both these are utilized to make the accurate control system. So accurate control system we utilize the background of the circuit. It is at the background you can see the motor controls are both. So this is Zener board. So this Zener board is here. This is a Zener formula produced at this board. So they are the 18 terminals. Terminal 1, 2, 3, 4 for the reverse and the forward switch. And so terminals are 9 and 12. We collect the 9, 10 and the 12 we use the speed control of potentiometer. So that kind of potentiometer. So we adjust the speed control potentiometer. So by adjusting the speed control potentiometer, you can regulate the excitation circuit for the tire star. So because of those things we use the SCR control system. So the SCR controls are firing angle. Firing angle can be adjusted by adjusting the speed controller potentiometer. Then motor speed will be adjusted depending on the kind of the firing angle. So then that speed can be measured. The speed measurement is normally the speed output with the voltage. So this voltage we use the speed meter. Speed meter is similar to the tachometer. So the voltage and the speed is proportional. So by this way you measure the speed. And speed controller is similar to the position transducer. So this kind of systems are utilized in the motor control system. So it is a transducer. It you sense and monitor the change in the surface shape. So especially when the surface suffer a stress or strain or vibration, wave, force, expansion, acceleration, those things make any changes in the surface of the metal, surface of the material. So in this case, those are amount of the stress, strain, vibration, wave, force, expansion, acceleration can be measured by using a strain gauge. So basic principle, according to the equation, strain gauge based on the equation R is equal to rho L by A. This means the R means the resistance, rho means the resistivity, M means the length, and the A is the area. So it is R as resistance. So it's a resistivity. A is a length. A is a cross-sectional area. So the any metal, the resistance value depending on the equation. So resistance value is depending on the R equal to rho L by A. So when you are connected this into the circuit, the electrical current will be flowing. The current will be flowing. So in the meantime that you change the area or the length of the metal, so the current value will change. The current value will change because of the resistance change. So the how to measure, you can use a solid one typically change. In this case, the better thing is that you use a spring one. Spring you can easily change the spring length. So this is called the length of the spring can be changed. So the instead of the system thing, we use a spring. The spring means that when the force is a compressed spring. So this is the force compressed spring. So springs are length will be changing. Spring length change means that resistance change. Resistance change means the current change. So by measuring the current amount, you can analyze it. You can determine the proportion as weight of the force. Value of the force you can measure. So that in this case, strain gauge is usually you measure the current when the force put the strain to the elongate or the compress. That the resistance will be changing according to the equation rho L by A, and the amount of current will also be changing. So that the change of current is proportional to the amount of force. So by this way, we measure the strain gauge. For the construction principle of the strain gauge, according to the I equal to rho L by A, the resistance of the material is highly proportional to the length, and the inversely proportional to the cross in the area. So that we attach a strain gauge. A strain gauge is a resistive material which can be directly attached to the surface or indirectly connected to the surface. So by this way, we can measure the when depending on the strain, the resistance value is changing. Also the current value changing. So by measuring the current, you can determine the proportional stress. Proportional stress you can measure. So in this case, the strain gauge is a transducer used to sense or the monitor the change in the surface change caused by the stress, strain, vibration, weight, force, inflation, and oscillation. This is a constructed S-pattern diagram so that the stress that can change the resistance and the flow of the current. So that now I give you the strain gauge circuitry because of the change of the current is and the body is too small. So that normally this body is you cannot directly measure all the measurement equipment. So you should use the appropriate operational amplifier. So that the change of the stress can produce the body and the current. So the current value is the signal value. So this will be small. So the small signal value has to be rectified by the amplifier. So we use the Wheatstone bridge and the amplifier to enhance the signal produced by the strain gauge. This is called a strain gauge. So strain gauge circuits the bridge is usually set at the balance. So when there's any change to the especially the active state, any change that we have to suffer the strain. So when strain is suffer, so it gets the resistance will be changing. So the change of the resistance can unbalance the circuit. So unbalanced circuit means that any signals are produced. So between the terminal is sensed by the operational amplifier. So the operational amplifier's sensitivities determine the value of the resistance component in the case. So that we want the constant current source, so that we have to provide the R5 and the R6. So by providing the R5 and R6, the bridge will receive as a constant current source. So this is for the strain gauge circuitry. In the strain gauge, we use a semiconductor strain gauge. For the semiconductor strain gauge, the typical resistance is 50 ohm to 10 kilo ohm. So K factor is the order of the 100. So this is the typical value. So this means that 50 ohm to 10 kilo ohm. So between this range, the strain gauge value is here. So this typical resistance strain gauge. The K factor is 2 to the 4.5, and the resistance value is 50 ohm to the 500 ohm. So now we can also see the K factor. The K factor is the constant for any strain gauge material for the amount of resistance change for a given strain or the force. So we can calculate the K factor equation that K is equal to delta R by R by E. Delta R is the change of the resistance, I is the original resistance, E is the force. So K is a gauge factor, so we can calculate. So this is the ways how we produce the strain gauge. The strain gauge how we can utilize the electrical current passing through and this current value will be changing depending on the chain of the resistor. Alternatively, we can also use the piezoelectric. Piezoelectric material means when the force is compressed, similarly the piezoelectric you see that your speaker is similar to the piezoelectric material. When the force are put on your crystal, the crystals are producing the electrical voltage. So that the electrical voltage is proportional to the amount of force exerted on the crystal. So similarly, you can see the microphone speaker. Microphone we use the piezoelectric device. So that kind of devices is we can also measure the force. In the force, so we can produce electric current. So this is for the piezoelectric material. Okay, up to this stage, we are talking about the transistor. So today lessons, I give you the speed measurement. So we use the tachometer and also the position measurement. So we use the potentiometer and also the source and the strain measurement. So in this case, we use the resistive strain gauge or the piezoelectric device. That's a two kind of the system. One way is process one is a phase regulating process. Because when the flow increases, the levels are in the then we reach until the head pressure increase. So when the pressure to increase, the valve will open. So this is called the phase regulation. But the second process is not phase regulation because the fan is plumbing out. Plumbing out, so that this plumbing out function and the entering action. So the difference between the entry and the fan out, the level will depend on. So that one is the first process is phase regulating, and B second process is not phase regulating. So which one got a linear response? So linear response got process 2. Process 2 got a linear response because of the level of the liquid depending on the entry and the exit of liquid. So there's a difference between the coming and going out. The level of the liquid is depending. So this called a linear response. The feedback system. Because the process one, we need a feedback system. Because of it, sometimes this level is too much. In this case, the valve cannot be open, so it can cause the overflow. So we need to send the feedback system for the process one. Regenerability means a maximum controllable flow to minimum controllable flow. So this is called regenerability. So maximum amount can be controlled to the minimum amount can be controlled. This is called regenerability. So another one is standard is the ratio of maximum controllable flow to in-source saturation to the minimum controllable flow. This is called a standard. Okay, so this is the system. In this case, regenerability means a maximum controllable flow to the minimum controllable flow. So in this case, the process control bar for that maximum to minimum ratio is only 50 to 1. But the process needed 200 to 1. 200 to 1 means it needs more capacity. Only one bar you can control. Because the process needs more capacity. So in this case, only one bar cannot be controlled. So you have to provide a combine instead of providing the one bar, you have to connect the two bar. The two bar in the CD, so by this way you can get the range. So in this case, I will utilize the combine the bar. That's the system. So that when the temperature is changing, a body gas of pure flow rate is horizontalized. So in this case, if you use the equal linear control bar, so what will happen? So we will see the thing. So this control is this is guys are not linear. Not linear, so guys are going this way. This is the original process where you like it. So this is the temperature change. But if you use the linear control bar, then we use the bar where you like it. So this is for the linear control bar. This bar is for the process temperature. Change. This straight line represent a linear control bar. So in this case, you see the sun difference. Before reaching the final stage, there will be the sun difference. During the intermediate stage, all those linear control bar sunlight cannot catch up that process. Process will temperature will higher, but linear bar will be lower. But at the final point, it will be the phase. So this is for the process system. If you utilize it as equal percentage changing, so in this case, your currency will be this time. So this guy is utilized for the equal percentage changing. So this is by using the equal percentage changing, so this equal percentage changing parts are also depress the change of the temperature. So by this is just the operation of the two bar. So in this case, when the temperature the changing is non-linear and you use a linear bar, starting the linear bar change, the adjustment cannot follow up the change of the temperature in the sun intermediate point. But if you use the equal percentage change bar, it can even put down the temperature. So this is the performance of the two bar currency and the real process. So quantities are minimum area and the minimum disturbance. So in this case, we can utilize most of the control loop. We use the QAD method. So the QAD response that stands the change of the system. So the proportional the change back to the minimum possible time. So with the leeway of the energy. So this is for the QAD method. So this QAD is really we call the quarter amplitude standing. So this is for the also for the QAD is quarter amplitude standing. Quarter amplitude standing means we don't allow to reach the maximum the value. For example, a circuit breaker. Circuit breakers are when the short circuit happens, so circuit breaker current, the short circuit current will reach the maximum. So as well as the short circuit current reach the maximum, it can only damage the insulation. So therefore, we cannot allow the short circuit current to reach the maximum value. So before reaching the maximum, we have to about the quarter of the value, we have to cut off the circuit breaker. So this is for the quarter amplitude damping method. Quarter amplitude damping method is that we don't allow the maximum value to be reached. All the disturbance we cannot allow the disturbance to reach its maximum value. Within the quarter of the magnitude, we have to set the control. The control has to step back to the normal. So this is for the QAD method. QAD response is commonly used on the most control loop. So the QAD is quarter amplitude response. QAD response returns the process relation PV back to the set point in the minimum possible time with the least waste of the energy. But however, the QAD response cycle for the 3 to 4 cycles before the PVs are stabilized case. So minimum disturbance is the cycling is the undesirable. The minimum disturbance response may be used. The minimum disturbance response achieved by using the less gain than required for the QAD. So, controller. So in this case, we utilize a microprocessor. So we utilize a microprocessor in the phase tuning that controller. So the function is to use the process reaction card. So to calculate requires a PID session. So we by applying the phase tuning controller, we just it can calculate the proportional integrate and the derivative control setting. So this setting can set up the any certain point to control the function. Okay, so the phase tuning controller commonly used as a process reaction card. Set the format to calculate the required PID setting. So the controller justifies making a small change to its output and measuring the resulting process reaction card parameter. From these controller, the controller then calculates the appropriate PID setting. So this is the second, it's a microprocessor base. So the any change is sent by the controller and it says set the appropriate proportional integrate and the derivative control setting. There are two kinds of bar. Bar should be the appropriate size. Undersize on the oversize cannot effectively control the process. So undersize bar is a bar is too small for the application. cannot provide the maximum demand required by the project. Oversight bias is the bias is too large for the application. So, if we normally operate near its closer position, causes a possible damage to the bar trim due to the high velocity. So, this is the disadvantage of the underside bar and the oversight bar. Underside bar is the bar is too small for the application. It cannot produce the maximum demand required by the process. Oversight bar is the bar is too large for the application. It will normally operate near its close position, causing a possible damage to the bar trim due to the high velocity flow through the small bar opening. So it operates the slow over which is part of the available bar travel leading to the power control. So this is more the possible cost made by the oversight bar and the underside bar. So this is why when you are designing the control loop system, the bar size should be the appropriate size. Now today's lesson is a speed measurement.